Well, well, well. Fancy meeting you here at the Daily Space Weather Show. The most action we saw was down there in the southeastern limb. The most flaring we've seen is in the northwestern limb. We'll tell you all about it here at the Smash News Network. Least busted name in news. By the way, we named that filament that erupted. That was known as the Marius Stan filament, named after the car wash owner on Breaking Bad known as Bogdan. And there he goes. The Marius Stan filament blasting off into the solar system. Is it earthly directed? Don't worry, we'll let you know later in the video. And shout out to all of our new YouTube and Twitter followers. We're terribly sorry if we triggered you with today's community posts. Here's a close-up of the Stan Marius filament blasting off. By the way, that's 171 angstroms 60-minute running difference, along with the 193 angstroms wavelength from SDO. Two different species of ionized iron there. And we've also zoomed out to show you the full disk. South Pole-oriented coronal hole there, rotating just past the Earth-facing zone and connecting with the polar coronal hole up at the heliographic North Pole, which is now becoming the magnetic South Pole. And let's take a brief moment to check out sunspots. These are the data from today from SDO, the SDO continuum, and we've seen a further reduction in sunspot numbers, so dropping down to about 70 sunspots now. Here's the colorized magnetogram for that same period. Today, December 30th to date, and let's see what's going on with earthquakes. So some eruptions certainly happening, including Klyuchevskoye producing a 20,000-foot ash plume as it explodes, 15,000-foot ash plume over Ibu as it explodes. It's a flight level 150. Flight level 150 over Samaru as well. Merapi also exploding. Continuous emissions there, at least at Merapi. Dakono exploding. About a 13,000-foot ash plume over Halmahera. Kilauea showed some seismic activity there. Alert level remains at yellow. Popocatépetl, no volcanic ash observed. Fuego in Guatemala exploding. Flight level 160. Flight level 220 over Nevado del Ruiz in Colombia. Mild explosive activity from Sangay in Ecuador. Don't mind it, it's just mild, no big deal. Revenador also exploding and producing a 15,000-foot ash plume. Sabancaya sporadic emissions, and that is where we will close out the volcanic list. Here are earthquakes in a convenient 90-day bar graph. And there was at least one significant earthquake over the past 24 hours. This one right here, located on the Indonesian Isle of something or other. Is it Papua New Guinea? It's Indonesia. It's Indonesia. So there is that 6.3 magnitude quake happening just north of Australia there. Let's call out the quakes of a 5 or greater magnitude like this 5.1. Deep in the South Pacific, where there are very few life forms. And then there was a 5.6 off the coast of Sumatra, 5.3 in the South Sandwich Islands, 5.1 at the Solomon Islands, a 5.2 at Papua New Guinea, and then a 6.3. Looks almost like aftershocks, right? Look at that. 5.1 at 1500, 5.2 at 1503, 6.3 at 1716, all right in a row from east to west. And then a lull in the activity there. Let's hope that's not a foreshock, folks. If a 6.3 magnitude is a foreshock, that would be unfortunate. No tsunami is likely caused by that quake, as it did occur on land. And let's get to some solar stats. The 10.7 centimeter radial flux now all the way down to 145 solar flux units. Next, there's the radial flux in a 1-year chart. The black line up top represents the radial flux. Again, 140 is the new number for the F107. Sunspot number here, again, it's down to around 70 sunspots at the moment. Space Weather Enthusiast dashboard forecasting a little bit of geomagnetic unrest on New Year's Day. And we are expecting that coronal hole wind stream to arrive sometime during the day tomorrow. So we're expecting the coronal hole stream to start to arrive still in 2023 as time runs out. Next, we'll show the last 4 hours of Earth's magnetic moment from space. Here's our geospace magnetosphere movie. And things have gotten quite calm in the Earth geospace. No geomagnetic storms or unrest. It's even calmer than it was last night. So we did see some aurora kick up last night. If you've got some imagery of it, share it with us on Twitter. Here's Earth's magnetic moment from the ground. Pretty unremarkable as far as the past 4 hours. Again, we're expecting the coronal hole high-speed stream density wave to arrive sometime, I'd say around midday tomorrow. As the hours draw to a close. The eons are closing, folks. Planetary K-index is at 1. KP1 is the current situation. KP1 is the average of global geomagnetism. Next, we'll look at the real-time solar wind here from two different devices. The ACE. There is the ACE spacecraft located at Lagrange 1. Only 341 kilometers a second and a 2.67 proton per cubic centimeter solar wind density there. So quite diffuse and very slow. The Discover, even slower and more diffuse. Only 1.6 protons per cubic centimeter approximately there, and only 334 kilometers a second. So solar wind should show a significant signal when that coronal hole high-speed stream's density wave, the portion that precedes the high-speed portion. So it's coronal hole high-speed streams are preceded by a high-density spike, and we can expect that one to be, again, pretty significant. GOES magnetometers are smooth. Top view ecliptic plane field plot shows Earth in a South Pole sector. So that's actually the past 4 days. And a North Pole sector is coming. Looks like it's about 18 to 32 hours out. So we could see a North Pole sector boundary crossing by tomorrow's daily space weather video. Here's our line of sight field plot. So the North Pole sector is imminent. And here is our line of sight coronal hole plot, which will be the source of much debate. Not the coronal hole plot, coronal holes in general. I won't get into it in this video. It is the daily space weather. Anyway, that coronal hole is now awesomely connecting with the north heliographic coronal hole. They are all of South Pole orientation. So this is all south. And these new coronal holes rotating in over here are North Pole. So that's the situation. A very long, but not very wide coronal hole, likely to result in a fairly short-lived coronal hole high-speed stream. And before we get to sunspots, let's do a little cosmic ray update. We haven't done them yet this week, I guess, so here we go. Cosmic ray update coming at you. We're going to go backwards through the list. DOMB Antarctica showing a tiny uptick, almost flat over the past 30 days. A small uptick at DOMB Antarctica. DOMC Antarctica showing a bit of a downtick, like most of the rest of the monitors. So that's the past 30 days right there. Slight downtick at DOMC, almost flat at DOMB. Oulu showing a modest downtick, almost flat there at Oulu, Finland. Next, down to Mexico City. Almost flat there, but slightly down for the past 30 days at Mexico City. Next, the Athens neutron monitor. Also down slightly over the past 30 days. Almost flat, but slightly down. Last but not least, Barentsburg and Apatity. Barentsburg showing a modest downtick over the past 30 days. And Apatity showing a similar graph. So overall, cosmic ray flux decreasing here over the past 30 days, and you can expect it to continue to decrease for another 10 months or so. Might even be more like 15 months. I won't get into why in this video, but I will get into sunspots, which are next. Sunspots, currently at about 70. Maybe 69 is the sunspot number. Here's a flare probability monitor and scoreboard. Likelihood of large flares mainly in that northwestern limb. However, there is a new threat rising right over here. So there is an increased likelihood also in the northeast. So the northeast and the northwest are now the most likely spots to see large solar flares. New active region is rising in that northeast. So here is our 24-hour SDO continuum imagery. That active region just north of the equator. And let's move to relativistic particles. Proton flux remains flat. And we'll have an increasing likelihood of a spike in the proton flux when that coronal hole high-speed stream shows up sometime after noon tomorrow, universal time. And there's our X-ray flux. It's now back into the C-class background level. About a C1 is the background X-ray flux now. So a little increase in the X-ray flux here in the past 24 hours. No major flares, only C-class intensifications. And here come solar flares from SDO. Keep in mind, this is not X-rays. This is extreme ultraviolet light, 94 angstroms ionized iron. And indeed, there is an active region rising. Over on your screen left there, you can see some flaring coming from that new region about to rise over the eastern equatorial solar limb. So again, two spots to watch. The northwest in your upper right, and the east over there on your left. There's 131 angstroms, the hottest of the AIA wavelengths that SDO covers. Next, we'll show a star chart, perhaps for all of you astrologers out there. Shout out to all of our astrologers who watch the channel. I'm not offended by this, as cosmology looks more and more like astrology as time goes on. Check it out. The twins Castor and Pollux have just risen there over the eastern limb over Lehigh Valley, Pennsylvania. That's skyandtelescope.org's star chart. And of course, you can find them easily because Orion's belt stars point at Betelgeuse. Betelgeuse is right between Orion's belt and Castor and Pollux. So there you go, Castor and Pollux there rising over the eastern limb. Also Jupiter and Saturn visible in your early evening skies. Next, your solar system forecast. We'll show you things today, that's where heavenly bodies are now. That's where things will be on January 6th, as time continues to run out for this year. Next, our astronomy photo of the day. The moon, oh my God, it's melting onto the Italian Alps. Just kidding, folks. Those are atmospheric layers that are causing that difference in refraction. Since down here you've got to view the moon through more layers of atmosphere than up here, where the atmosphere is not going to be as dense. There's less atmosphere when the moon is overhead. That's the astronomy photo of the day, courtesy of Giacomo Venturin, apod.nasa.gov if you want to check it out yourself. And it's time to move on to CMEs. Yes. Here are yesterday's. That's 92 frames, and right at the beginning of today, you'll see the Marion Stan, what is his name? Stan Marius or something? I don't know. I can't remember. I agree with Einstein, who said never memorize something you can look up, but by the way, you can find his name on our Twitter, x.com/smashomash. Thanks again to our new Twitter followers. We're frankly surprised you see the tweets. You probably got to look at our profile to see them, considering the state of, suppressing facts and things on the internet nowadays. You know how it is. Anyway, we've got some CMEs to cover, so let's get to it. Here are LASCO C2 and C3. That last imagery was just C2 and difference imagery for the LASCO C2 coronagraph. And let's move in a little bit closer here, as some of these, do they have earthly directed components? You might be wondering. Well, don't worry about it. We'll cover it. Let's let those play through first. So here we are early this morning. There goes the Marius Stan filament blasting off to the southeast, and we don't think that'll be earthly directed. That is way too far south and way too far east to be likely containing an earthly directed component. So here come our custom coronagraphs. There's the zoom way out. That is a 24-hour video. And those other CMEs out of the north and west, those are from the far side. We don't see any plasma motions or limb darkening associated with those other CMEs, so no new earthly directed CMEs, but there is a coronal hole wind stream about to arrive. We're less than 24 hours from the high density portion of it, in my opinion. Here we've subtracted the LASCO C3 and added the 304 angstroms running difference. It should show some additional contrast in that southeastern filament eruption. And here's a fantastic view of that in those same wavelengths. And I guess we can get in a little bit tighter on that, right? There's the equatorial zoom. I'm sure you all want to see this zoom. Great view of the filament eruption as well as the Hyder flare, which is the brightening you can see after the eruption takes place. That is plasma splashing back down deep into the lower corona, down toward the chromosphere, the layer between the photosphere where sunspots occur, and the corona, which is what you're seeing in the SDO imagery, at least the AIA imagery. So fantastic view there of that southeastern CME filament eruption, coronal mass ejection, whatever you'd like to call it. And next we'll get to filaments. Filaments. There you go. And this one up here is still looking pretty unstable. That is 4 days, actually. And here's some more imagery from Cerro Tololo. Look in the lower left, you're going to see the Marius Stan filament go blasting off. Wait for it, and whoops, there it goes. Quite a bit of instability happening up there in the northwest, the upper right. So again, don't be surprised to see a major CME come out of that area. It'll be unlikely to be earthly directed. And we do have actually a crown prominence happening here and some flaring as we create the video. That is the GOES 16 SUVI for the past about 3 hours. And there's the full zoom so you can see the time and date stamps. Next, bonus features. Yeah, bonus features. You got to have them. We used to make them separate. And guess what that did? Reduced our views on YouTube. So now they're all in one video. Cheers. That's what's up, YouTube. Anyway, many of our viewers prefer longer videos anyway, so that's what's going on. As far as charging hazards, we ain't got none. It's smooth sailing for satellites. Electron flux here in a normal operating range. That's nominal, pretty unremarkable. There's the past year of electron flux, the relativistic electrons, as measured by the GOES 16 and GOES 18. Next, the forecast model, and indeed NOAA is forecasting a big dip in the electron flux. I would tend to agree. So, agree with that forecast, represented by the green boxes. We'll also show the layer where it's measured, the F layer of the ionosphere. So, feel free to pause the video on that frame if you're not familiar with distances in kilometers. There is the F layer. And things are very geomagnetically calm, even more geomagnetically calm than they were last night. So don't expect to see a lot of fireworks on that. If you were hoping to have us forecast the apocalypse using the ionosphere data, well, you'll have to wait till a different day, because there is absolutely nothing spooky or bunker-worthy about that. The anomalygram looking quite unremarkable as well. That's anomaly in megahertz from the 30-day median. Next, the WAM, the whole atmosphere model, which is the global ionosphere nowcast. Total electron content and anomaly on the left, maximum usable frequency and anomaly on the right. It almost makes me want to get rid of the total electron content forecast, which I've just done. We'll close out the daily space weather content with the latest continuum and latest colorized magnetogram. There is the full disk. And here's this new likely sunspot. Do we see any umbrae yet? Well, the answer is no. No umbrae yet over there. But we do see some magnetic field organization rising. That is likely to be a sunspot, as we've already seen some flaring from it, so that is unlikely to be just a plage. Anyway, next meteorology. And we're starting out meteorology with this. Get a load of that, folks. What's up with that? Any guesses on where that's located? That's the world's largest waves. Where do you think that is? You think that's off the coast of California? I mean, it does show the coordinates there, but those are some 30-foot waves. And, folks, the seas are actually very calm right now. So this is in the Southern Ocean, or just next to the Southern Ocean, in the southernmost Pacific. Some 30-foot waves down there. And besides, near Ireland, nothing even comes close to that. Those are the largest waves. Ireland has the second largest waves. And I've heard a lot of talk about waves. But, again, the seas are quite calm, folks. Not a lot of big waves on planet Earth. So anyway, let's get to our regularly scheduled meteorology segment. There are the surface winds of the east. Shout out to our viewers from this side of the map. There are the jet streams of the east. Jet streams of the central world. Shout out to our viewers from Europe, Africa, and the Middle East. Here are your surface winds. Surface winds for the west, shown here. Shout out to our viewers from this side of the planet. And there are our jet streams. Doubled up jet stream over the U.S. there, pulling cold air way down into the Gulf of Mexico. And some very, very cold air moving due south into Minnesota. We'll get to it. You'll be able to see that low making its way across the Canada-Minnesota border. And if you can't see it there, don't worry. We'll get a little closer. Don't be shy. Get a little closer. That air is more moist than dry. Anyway, there's that low. You can see that counterclockwise rotation characteristic of the northern hemisphere low. Some very cold air, some frigid air not the refrigerator, the cold air from Canada. Here's our humidity map showing relative humidity. You can see all the dry and moist places of the planet from windy.com, who I would reiterate does not endorse anything we say, nor have we asked them to. However, they do provide a free app for your smart device at windy.com. So you may want to check it out. If not, I don't care in the slightest. Next, our weather.gov map. Some freeze warnings there in Florida and Georgia. And let's just scroll back up to stop showing the key and just show the map again. There's the weather.gov map. Weather.gov is where to get your weather warnings. And here comes some weather forecast. Now we're starting things out with the jet stream, because the jet stream is the real culprit that drives your weather. So that's the 72-hour jet stream forecast. It's the GFS model. Next, pressure and precipitation. Same model, GFS 72-hour. Next, total accumulated precipitation, GFS 72-hour model. It's precipitation in inches, by the way. We'll also show total accumulated snow depth change. Positive accumulated snow depth change in inches, 72-hour GFS model. As half of Pennsylvania is going to be covered with snow quite shortly. Just not this half. And last but not least, temperature anomaly in degrees Celsius, 72-hour GFS model. Ta-dow. Ta-dow. Next, lightning. As a thunderstorm continues for days in the subtropical Atlantic, slowly making its way up toward the Azores. And here's a real-time lightning map, courtesy of lightningmaps.org. About 100 strikes per minute at the moment. And before we close out this video, don't forget to press the like button. Otherwise, there will be hell to pay. There is only limited time for you to press the like button. Because if you don't, there will be ramifications. Don't make me ram ramifications up your subscription feed. Ramifications. Press like. Or else. Do you want your soul cast into an ever-deepening and darkening abyss of bad, ridiculous content on the internet? No? No? Then press like. If you're new to the channel, press subscribe. Do yourself a favor and get the world's most comprehensive daily space weather content and most detailed solar imagery. If you want to contribute to the content, one of the things you can do is head over to smashomash.com/forum. We've got an Ask a Particle Physicist segment over there. smashomash.com/forum if you want to submit a question for a particle physicist. We usually air those on Fridays. Pretty simple. It's completely free. smashomash.com/forum, launched back in 2019. You can link to it from smashomash.com, our homepage. And welcome to the Neo Renaissance. Once again, congratulations on realizing the channel exists. Thanks to our new YouTube followers, etc. Cheers. Visit the links, support the channel if you'd like it to continue to exist, remain publicly visible, and free for all to view. Incentivize us, and perhaps we will even expand our content. We're closing this thing out with U.S. Doppler radar, clouds and fog, and water vapor. There's the full 50-state view briefly. Here's the lower 48 view chiefly. Here is the clouds and fog scenario. And there is the water vapor map. Lots of dry air over the Gulf. It looks like clear skies over the Gulf of Mexico. Here's your recap. Vertical motion in the air column from ground-based Doppler radar systems. Space-based infrared radiation, 3.9 micrometers showing clouds and fog even at night. And 6.61 micrometer infrared radiation showing water vapor as in all of it. It shows dry air. It shows moist air. And now we're showing me getting back to the bunker. Got to make sure that I have enough bunker supplies for 2024 because people tell me that 2024 is going to be very spooky, folks. So I've been listening to all the charlatans and flim-flam bamboozlery artists on YouTube, and my bunker is so stocked, folks. It's so stocked. I mean, I feel so safe now, folks. So I'm going to go try to hide from space in a bunker. Anyway, see you soon. 'Cause I'm going back to the bunker again. I'm always climbing down this ladder as our videos end.